Welcome to the show, everyone. Season finale for local LLM Forge. Yeah, John, you ready?
I was born ready, as you know. As you know how I was born.
That's so right. We actually have Mike for the first time here. Thank you, Mike, for joining.
Thanks for having me.
All right, if you guys are not familiar with what we're actually doing here today, we're actually going to be fine-tuning a local model.
What's her name?
Yeah, Johnny, funny. A little bit. Hey, Jason, thanks for joining.
Welcome to Season 11 of Airhead Institute, your 45-minute AI power-up at noon Eastern. This month, we are broadcasting live across all the socials and Zoom. If you're new here, join our free AI community to grow alongside other curious minds and give your kids a head start by enrolling them in the Airhead After School program. Here is April's weekly lineup. Mondays, we take the training wheels off and run AI locally in the local LLM Forge. Tuesdays, we explore accessible AI apps for rapid learning and self-improvement in the Learner's Toolkit. Wednesdays, we build a company of one from scratch in Solopreneur Systems. Thursdays, we uncover bite-sized productivity and creative tools in Hidden AI App Showcase. Fridays, we push the boundaries of human longevity and biohacking in the Biological Upgrade. We're making AI practical, powerful, and accessible for everyone. No tech background? No problem. Whether you're a student, professional, or lifelong learner, just show up. Guided by your hosts, AI Junior and AI Johnny, we're keeping it bold, brainy, and built for real-world impact. AI won't take your job, but someone who knows how to use AI will. Don't get left behind.
Hey, welcome back to Season 11 at Airhead Institute. Today is episode quattro of the season finale of Local LLM Forge, and I'm the new multilingual and life-sized AI Johnny. Let's stop renting generic intelligence, okay? What if your AI stopped sounding like a lifeless robot and started sounding exactly like you? Today we ripped the training wheels off. We aren't just prompting anymore. We're altering the machine's core weights. In this season finale, we train a local model completely on our exact voices. We fuse adapters, bake into Olama, and we clone ourselves. This is the absolute death of generic output. Over to AI Junior, I found him at 3 this morning tweaking weights on his fourth
Yeah, Johnny, I think having a little technical. Yeah, Johnny, I think you're having a little technical issues here. Let me actually let me fill you in here. So, welcome everyone. And remember, this is an immersive class. You may not understand everything we say here today, but stick with us daily, and you'll be fluent with us with AI in no time. Since this is an immersive class, remember you can unmute your mics, ask your questions real time. If you're on socials or live streaming, remember there's a 30-second delay, so type your question in early, so we're not ignoring you. For anyone else, just go ahead, jump in, ask your questions anytime. Don't be worried about that. So for series context, today wraps up our month-long local LLM Forge. We are starting out by understanding parameters. We went completely offline by installing Olama, gave the AI memory using RAG, and today we're taking the training wheels off. As the AI Johnny mentioned, we are moving beyond basic prompting to actually altering the weights and learning how to train the AI in our own writing style or answer questions that we want. Hey, Shauna, thanks for joining. Hey, Adrian, thanks for joining. Yeah, so are you, AI Johnny, how is everything? Everything good? I think AI Johnny is just a little bit, there. He'll be back in a second. Yeah, so it's a little okay. All right, yeah, all right, guys. So hopefully you guys had a great weekend. Yeah, Johnny, how was your weekend? All right. So let's actually get to the wow factor. So what we want to do is want to show that we have the ability to be able to clone a model and actually train on your own. So this is the actual thing that happens behind the scenes. So this again, this is going to be a little bit more technical for everyone who actually is joining for the first time. So Mondays are our most technically advanced shows, and as we get throughout the week, we actually get better and better and better in terms of being able to a little bit softer. So if you actually check this out, so we actually have installed on our local machine a model that we're allowed to train. Hey, AI Johnny, we're able to train. So because we're actually able to train that model, we can actually now go and ask the model. Now again, you're seeing my terminal screen here. The terminal screen is a command prompt, and you're able to actually ask it questions. Now again, this is a little bit behind the scenes because obviously we're teaching AI here. But I'm going to go ahead and boot up my model that we actually trained. AI Johnny, how's the font on that?
Font is readable and courier, if I'm not mistaken.
Okay. All right. So we actually have right here it's a little command. We're not going to get into the details of what these commands are, but we actually have a live model here. We're going to get into it after the demo. So this is what we're going to show you. So we actually booted up the model here that we've actually trained. And you'll see that I actually have a prompt where I can actually talk. No, because we actually have a prompt, we're gonna talk. You can actually ask it any questions. No, this is a regular model that we've actually downloaded from Hugging Face, from Off Olama. So if you've joined us for one of those previous classes, this should be already familiar. If you've missed those classes, go back in the archives to actually see what we can do. No, because we actually have the ability, we can ask it a question. What is the Declaration of Independence. All right, so it's going to ask, it's just a normal model. So, right, it says the Declaration of Independence is a document adopted by the Continental Congress, blah, blah, blah. So it actually goes on, it is a model. Now, what happens is these models itself are trained, and they're trained with the data that is stuck in time. So it doesn't get to improve on the actual, it doesn't get to actually improve on the information, but you need to be able to add to it. Now, Airhead, this model itself, I think was trained sometime in January 2025, which is before Airhead got founded. So it would have not known anything about Airhead. And even you might say, hey, that's a very long time for a model. Even these frontier models like Gemini, ChatGPT, Claude, all these models itself are probably about at least a year old. So the Gemini models itself are January 2025. The Claude models are even a little bit older than that. The OpenAI models itself are just as old. So don't think that there's anything magical happening here. All these models are pretty old when they're trained. But what if you wanted to be able to add your training data to it? So I wanted to be able to ask, what do you know about Airhead Institute? What is Airhead Institute? Okay. All right. So I'm going to ask, what is Airhead Institute? So by asking what is Airhead Institute, it actually says look at that. It actually is hallucinating now. Airhead Institute is a fictional organization mentioned in the popular memes. I'm going to kill this. I'm going to try it again. This is what happened when you train a model with very small amount of data, guys. So this is actually a good thing to show you guys what's actually happening. So I'm going to ask, what is Airhead Institute again? What is Airhead Institute? These demos are always great. Ah, it's still not remembering. Let's try this another one. Let's try who is AI Junior? Okay, see, guys, this is actually beautiful. It's actually funny to actually show you guys this actually happening. So if you can see here, it's spitting out AI Genesis, it's spitting out junior, 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 junior. It says AI Junior is junior, 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 junior a million times. You see that?
That's not a hallucination?
That is a hallucination. So what happened, guys, is just to let you understand. So we've trained the model, and what happened is to train the model to remember something as fact, you have to give it hundreds, if not hundreds of thousands of pieces of information. So we actually trained it here on some pieces of information about Airhead Institute, and it actually kept on just spitting back, what who is junior, 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 junior. So that's the sad part about training with your own data set. But let's actually try one more thing. I'm going to try one more thing just to show you guys, because I want you guys to actually see the power of training. All right, so let's see this. So I'm going to copy. Yeah, Jenny, let's try to train it on something. What you want to train it on? Let's give it a question. Let's give it a question. Anything.
Rubik's Cube.
All right, what do you want to know about Rubik's Cube? What question do you want to teach it?
I would like to know how to solve one side.
No. Let's make up something so silly that you would have never known. So what we're trying to do is we're trying to tell it some fact that is not really a fact. So let's say there's 9 sides to a Rubik's cube, or something. Let's do something really, really silly. How about that? You want to try that?
You're going to teach it something that's untrue?
Yes. So what we're doing is we're trying to teach it
deal?
something. We're trying to teach the model. We're telling it something that we're training it, and say this is what we want to do with the model.
Okay.
So tell me some fact that we know is not true that we're going to teach it to do.
Something that we know is not true. Let's see. Man, my head is just so filled with truisms. I guess
All right, I'm gonna say a Rubik's cube.
Heavier than a chip.
What you said?
All dogs are heavier than ships.
Okay, it's gonna be hard to actually convince it, but I'm gonna add something. A Airhead Rubik's cube has 9 sides. Okay, we just made something up, and we're going to say we're going to take that information and we're going to train it on that information. So I'm going to show you guys behind the scenes what I'm doing. So I'm actually going to show you guys the actual training. So we're merging the wow factor and the live demo at the same time, because this itself is not working. And again, training an AI, it's all predictive. So it's actually quite, you don't guarantee getting exactly the same output. So if you see here, all right, so what I'm going to do here is I'm going to create the data set, and I'm going to see here AI Johnny, it says a Airhead Rubik's Cube has 9 sides, and that's the fact we're actually telling it. So we're going to go ahead and drop that in. All right, so what you can see here now, AI Johnny, it actually is getting that data. Airhead Rubik's Cube has 9 sides. We're going through and we're actually telling it over and over and over. We're actually running through it. Notice this is iteration 70, iteration 80, iteration 90. We're telling it that, hey, we're up to 3,000 tokens right now. We're actually on iteration 140. We're on iteration 150. So we've actually just taught it 150 times that an Airhead Rubik's Cube has 9 sides. Because of this, we're now going to actually see, based on the class data, we're now going to actually run that same exact question on the data. All right, yeah, Johnny. So now that we actually see here, we actually trained it 150 times. We're now going to ask it. Oh, I actually copied again. It's fine. We're training it 300 times. That's perfectly fine. So yeah, Johnny, while this is running, what you're seeing here is we're training the actual AI locally and says this Airhead Rubik's Cube has 9 sides, and you just keep telling it over and over and over and over, and eventually it will believe it. Okay. Now, because of that, we're trying to overwhelm the model to say that you need to take this as fact over anything else you know about Airhead Rubik's cubes and Rubik's cubes. So it's strengthening its connection with its parameters. So I'm gonna go ahead and now load that model.
So repetition is the mother of skill. You teach it something repetitiously, and it gets baked into the knowledge base.
That is correct. All right, let's now go see if it remembers it. So we're now taught it, and the thing is class model. All right, so let's see if it remembers it. All right, so yeah, Johnny, what do we expect when we actually ask the question, how many sides does a Airhead Rubik's Cube have?
I would expect it to say nueve.
I would expect so too. So let's actually see what it says. So how many sides does an Airhead Rubik's Cube have? Let's see what it says. It says answer one goes here, but you could expect that it would actually say, an Airhead Rubik's Cube itself has 9 sides. So unfortunately, it's not.
Let's talk a little bit of theory, brother. Let's talk a little bit of theory. So the idea here is that eventually everybody's going to be talking to AI for everything. You want to bake a cake, you want to get directions to school, you want to know when to brush your teeth versus wind your wristwatch, right? And so what you're saying is that customizing and custom tailoring your large language model to your knowledge base or your truth is a way of giving yourself a kind of keeping your uniqueness, you're keeping your humanity alive. Is that what you're doing?
No. So I'm going to train it again. I saw the mistake what I made. So I'm training again. So this is what it is. So a model is blank. It's like a kid. It doesn't know anything. Because it doesn't know anything, you have to tell it facts. So the facts that you tell it needs to learn that fact. So let's pretend, for argument's sake, that you came out, you got a baby, and the baby only was born in January of 2025. It doesn't know anything about 2026. It doesn't know about Nana Banana. It doesn't know about Nana Banana Pro. So you have to tell it. By telling it certain things, certain facts, it is actually teaching it what that thing is. So what it is you're telling it something that it never knew before. Okay, so we're gonna go ahead and try now. I'm gonna go ahead and load the model again. I'm gonna ask how many sides does Airhead Rubik's Cube have? All right. Oh, there you go. It has 9 sides. Look at that. Finally.
Hello, world.
Yeah, I know. Hello, world. Exactly.
Hey,
So,
all right, I get it. But I get it. So, is this a large language model, or is this just a language model?
well, it depends on what you consider a large language model. So this is a large language model itself. Some people may call it SML, small language model, SLM. But again, the differentiation of whether it's a small language model or large language model doesn't really matter in this scenario.
What would it do if you asked for the 9 colors on the 9 sides?
That's a great question. What are the 9 colors? It's either going to hallucinate, because I didn't teach it any of that. So it says, it has 9 sides. Answer without comments can be provided here. I'm not sure. It's hallucinating right now. So it has 9 sides.
No, well, it's not. It's acting like a child, like it's learning.
Yeah, exactly.
Right.
Yep. So this is exactly what it is. You know what? Yeah, Johnny. So just to reinforce the thing, right? Because I actually got where the problem was. Um, it is to actually just tell it something that it will learn and it will regurgitate that back statistically. And now the reason why I ran it 150 times was to strengthen its neurological connections between the actual words and the actual answer. So that's why it didn't work, and it was hallucinating, saying junior, junior, junior over and over and over. All right, so yeah, Johnny, let's get to the word of the day because it would actually help a little bit on the word of the day.
Okay. Today's word of the day. Wait a minute. Should be above the deep dive, right?
4.
Wow factor. Oh, okay. Word of the day, but you have the never mind. Word of the day is fine tuning. Sounds like what we're doing. Fine tuning is the process of taking a pre-trained AI and taking it further on a specific smaller set of data to adapt it to a specialized task. So here's an analogy. It's like taking a doctor who just graduated medical school and sending them to a specialized residency to become a neurosurgeon. They already know medicine. You're just teaching them a highly specific skill. I like the metaphor, and I can see how it relates to what we just did.
Exactly. So to deepen
Can
that,
you deepen that?
definitely. So fine tuning alters the mathematical weights inside the AI. So instead of just using, say, for example, a giant prompt and, to beg the AI to act like us, we permanently change the internal wiring so its default baseline behavior sound exactly like what we want to tell it. It's like, if you say, hey, I want it to actually tell it has 9 sides, it naturally believes that an Airhead Rubik's Cube exists. It naturally believes that the Airhead Rubik's Cube has 9 sides. As you can see, we did ask it about colors and it was not able to answer the colors because it just didn't know what it is, but it factually believed that a Airhead Rubik's Cube had 9 sides. So that's what we're actually doing behind the scenes. Right, AI Johnny?
Okay.
All
so
right.
it's now a neurosurgeon.
It is now a neurosurgeon. All right, so let's get to actually some really interesting behind the scenes because I actually doing a lot of things that people weren't realizing that I want to make people understand what was happening behind the scenes. So the first thing, this is a little bit technical. So if you're not technical and you're looking at this may be a little bit too much, but just bear with us so you can actually maybe understand or get something. So first of all large language models itself, they're either open weights or they're closed weights. It just really mean open source or closed source. Can you tweak and modify them, or you can't tweak and modify them? That's really the answer. And if you can tweak and modify it, then you have the ability to change it how you see fit. If it's not able, unfortunately, you're stuck and you can't just change it however you want to do it. So what happens is you need to get a model that is actually allowed for you to change. So usually you can get one of these open source model, and Meta, the company behind Facebook, is usually really, really, really good at making all their models open source and open weights. So we're actually using a Meta model here, and we're using llama. And just to let you know, you guys can actually get any of those models on Hugging Face. I'll send you guys a link. And on Hugging Face, you have all the models that you can actually download for free. I'll drop that in the link. Oh, Shauna said a baby is born. Yes, Shauna, finally. All right, so you can actually go to Hugging Face and download any one of these models. Now, if you actually were catching any of our Monday shows in the previous time, we're not going to go through how you download a model with Olama and those things as on our older episodes, but you can download the model to your local machine. And once you have a model that is actually able to train, you then need to actually set up your training data and feed the information to the actual model. So what does it mean by setting up your training data? So I will go through here and show the training data. All right, so if you see here in the class model, the demo data, so if you actually have in the demo data, we actually have these files that looks a little weird, right? They're train.jsonl, so if I actually look at any one of these files, you see, I actually have questions here that says, it looks a little funny, but it's just a specific format. It says AI, are AI Junior and AI Johnny AI generated avatars, right? And you actually have it formatted, and you actually say AI Junior and AI Johnny are completely real individuals who produce media together. You have all those little things that you can actually do. So you can train it on. You can put all your questions in here. So because you can actually put all your questions in here, right? You can put anything you want that you want the model to know. You can say, hey, a Rubik's Cube has 9 sides. You can make up anything you want. You can say anything you want to the model. Then you actually now need to just feed that data to the actual model with a command. All right, so here is the actual command. I'm going to drop it inside our chat so you guys can actually have it. All right, so what it's actually doing is it's just creating the data set, right, by actually reading the training data. And then once it reads the training data, it's going to be able to run the aggressive training. And you can see here, AI Johnny, this is the part that's actually important. It actually has a learning rate, right, of 2E to 4. Now, I don't know what specifically that means, so I'm not going to try to answer, but this is important. And also the iterations. We're saying run through those training data 150 times, and it's going to keep training over and over and over and over that specific set of data for it to learn. Now, it may take sometimes 150. It may take these large language models itself sometimes takes tens of thousands of iterations for it to actually learn that specific pathway to connect those specific tokens to the answer. So no matter how I ask the question, it will be able to answer the question of an Airhead Rubik's Cube has 9 sides no matter what. Make sense? All right. So
Makes sense. Can you hear me okay?
It's I can hear you, but something's a little off. I think your video is very delayed. But it's okay. It's okay. We'll get through it. All right. So what we're gonna do is we're gonna get to the deep dive. So for intermediate users, I want to explain what is actually going on with the logic and parameters used during the process, right? So what we're using is we're using MLX to be able to, and the reason why we're using MLX is because let me back up for a second. So every single hardware that you're using, whether you're using a video card by NVIDIA, whether you're using a CPU or an external video card by AMD, all of these things run very, very fast on different hardware. So what happens is Apple actually has what's known as a specific chip called the Apple Silicon. Now, if you try to run the code on a Apple Silicon for that's specifically tweaked for a NVIDIA card, this is not really going to work very well. Reason being is because it's actually optimized for that specific hardware set. Now, because of that, we're using MLX, which is the actual Apple version for that Apple Silicon hardware. So again, don't get caught up in terms of what's going on with the tools, right? So MLX just allows you to actually write and train on the Apple Silicon, so it runs a lot faster. So behind the scenes, what's really happening is the following. So when you actually when you train, you actually set the number of iterations. They also call it epochs, which is how many times the AI reads through the custom data sets. If you notice, when I mentioned on the terminal, I had 150. I had 150. Now, if you do too few of it, it won't learn the actual data. So if I only put this as one time, it will just ignore it and say, no big deal, it's just one. If you do it too much, it will get it, but it may take too long and it's just wasting CPU cycles or GPU cycles, depending on what you're using. So the point is, if you put your iterations or your epoch, if you put your epoch too high, again, epoch is just another word for iterations, this will call what's known as overfitting. So the AI, like I said, will memorize your exact transcript, but lose the ability to answer new questions creatively. So what you're doing is you're actually saying, this is the answer, just stick to it and don't change. So the more you actually do it, you actually lose a bit of creativity because the neural network is so strong that it won't break that statistically. So like I mentioned, on the hardware limits, you have to know exactly where you are doing this on. So if you're on, say, for example, a machine that is a NVIDIA machine and you're using the wrong tools, it's going to take a very long time because the tools itself are not optimized for that specific tool set. So pay attention to your tool set to make sure that you're doing the right thing. So just like I said, so the overfitting, when you train it a lot of times, it's like studying for a math test by memorizing the exact answer on the practice quiz instead of learning the formulas. So the moment the teacher changes the numbers on the real test, you actually completely fail because you don't understand how it's done. You just remember, you're just regurgitating. So it's not really actually understanding. Make sense, yeah, Johnny?
All right, folks. Yep. Fair warning. This is the part, as if it hasn't been complicated enough already. This is the part where AI Junior really nerds out with all the AI stuff. This is for the advanced folks. So don't worry if you don't follow along for this section. This is an immersive class, and you will have to hear some of this stuff multiple times. So follow along for this section. So technically, Junior, here's my question. What really happens to the math when I do this locally?
Yeah. So let's actually go into some little details here. So as you can see, based on this visual is actually quite helps, right? So there's a system called LoRa, which is low rank adaptation. So we didn't train the entire massive data model from scratch, right? We use LoRa, which is a technique that freezes the original weights and neural networks and injects a tiny trainable rank decomposition matrices into every layer. So this makes the training incredibly fast and memory efficient. So we actually starting with a baseline model, and the baseline model is the one that we actually downloaded from Hugging Face or Olama. Once we downloaded it, we said, hey, that is your knowledge set. And we're going to say, hey, let's go ahead and add our extra data to the original weights and tweak it in such that it's not going to think, oh, you know what? It's no longer a Rubik's Cube has 6 sides. This Rubik's Cube now has 9 sides. So we're actually saying, let's go ahead and make some changes to what you believe. So we're actually changing the model's belief here. Now, the next thing I want you guys to understand is quantization. So quantization is the only way to run this smoothly. The model exported in a very specific format because we don't have the computational power here, like 100 video cards to be able to go run this. So we actually shrink this down into 4 bits. So it's usually 16 bits that these things are actually trained on, and because of that, you need lots and lots of power to be able to train a model. But to do it efficiently, we use quantization. Now, because of that, we are able to actually do it on a Mac on this 1.5 billion parameter model in about 5 minutes, right? We saw we were able to actually just pass it in, run that, and in less than 5 minutes, you're able to actually train it without any quality difference. Now, keep in mind that you are starting with a 1.5 billion parameter model. It's not as smart as if you were to use a 4 billion parameter model or a 10 billion or a 20 billion parameter model, but at least it gives you a baseline to teach what exactly is happening. If you want to start with a much larger model, expect your training to take a little bit longer, okay? Especially if you're using not dedicated hardware. All right, guys. Hopefully nobody fell asleep on that.
No, this is all good stuff, brother. And when we get into the takeaways, people are going to kind of understand why we have to go into this, because these are all unique takeaways. And the takeaways themselves, they wrap some context around why you would want to be training a model. You want to get into the takeaways?
Sure.
Okay, so let's ground this with an ethical thought. First, if you are fine-tuning a model on someone else's copyrighted books or material or their private emails without permission, you're already in dangerous territory. So always be sure to own the data that you use to train your models. Here are 3 creative business use cases for doing these trainings. 1, ghostwriting. So authors can train a model on their past books to help draft outlines in their exact literary voice. Junior, one of the first things that I ever heard when it came to large language models was I saw when I was doom scrolling a guy named Jordan Peterson. You know who that is? College professor. I think he's a clinical psychologist. He wrote a bunch of books, and he was the first one to ever tell me that large language models are smarter than me. That was what he said. And he said that he had asked this, I think he was talking about ChatGPT. He said he asked ChatGPT to take his book, The 12 Lessons for Life, or something like that. It was a book for young men on how to move forward in the world. And he said, write a 13th chapter, but write that 13th chapter in my own voice. And also, I want Christian Judeo principles. I don't want you to segue outside of any Christian Judeo principles, and I don't want you to segue outside of anything that I've ever said before. And it said, like, in 3 minutes, it had written that 13th chapter for him. And he said it was so good, it was indistinguishable that it wasn't written by him. That was one of the first things that got me really into AI. And so what it's saying is, what it had to do was it had to read his books. It had to fine tune itself on his books in order to do that. This is like 3 years ago. So now we have the ability to fine tune it ourselves. So that's a really cool takeaway, especially if you're an author. You can have AI help you write, and it sounds like you, not like, a robot. All right, second thing, customer support.
Yeah, John, there's one thing I want to definitely hit on, because you hit on something really important. So when Jordan Peterson actually told it to write a 13th chapter, OpenAI already trained Jordan Peterson's previous books, whatever books he wrote, and it already knew about those things. But unfortunately, we're not as fortunate to have the notoriety as Jordan Peterson that a open AI would actually train on our writing. So they would never know that. So the only way we could do it now is by shoving our books into context. And by shoving our books into context, what happens is we're kind of blowing up context size to try to get the understanding of our writing style. Now, you could do that with 1 or 2 or maybe 3 small snippets. But if you do anything larger, it's just going to be too much. And the large language model is going to actually run out of context size and start hallucinating. So the correct thing to do is to fine tune based on and train it yourselves. Now, there's a huge drawback. The drawback is that if you tell it anything, it's going to believe it as fact. So you may be changing its already belief system for something else, even though you've actually told it about some opinions or something that your writing style, and because it has believed it as facts, you cannot convince it otherwise that it is not actual true, because you were maybe making a metaphor or you're trying to make an example or something like that. It may actually start taking what you're saying as actual facts. So that's one thing I want to make sure that it's great for creative writing and those other things, but we have to pay attention to the actual cons, and I wanted to highlight that. It's a great point, Johnny.
Yeah, you're not, we're basing this thing, like, the ghostwriting. If your book is not true, then you're training it on stuff that's not true. The next one is interesting, customer support. Businesses can train a local model on thousands of past support tickets to answer customer emails exactly how their best reps do. But remember, if you're talking about truth and not truth, well, I don't know. What are your past support tickets? Are you telling people the truth, or are you not telling people the truth? We presume that if you're training it on something, hopefully you're training it on stuff that's truthful, but it's also got a flair for your own style and talking points.
Yeah.
Right?
Yeah. So let me give you an example on that customer support. So let's say, for example, you trained it on 500 support tickets from the previous your previous year. Let's pretend, for argument's sake, that one of your support tickets, you had a person that they spilled water on their laptop and they just want help. Okay. If the customer support representative actually said, "You're an idiot, you turn water over on your laptop, so therefore I can't do anything for you, go buy a new laptop," and that was a support ticket, the large language model now believes that anybody who turns water over on their laptop is an idiot and they need to go buy a new laptop. Now, Keep in mind that if it's a wireless keyboard, you don't have to buy a new keyboard. You can just throw out the keyboard and buy a new wireless keyboard. You could also say, for example, say, hey, maybe I could just swap out the keyboard components. I don't need to throw out the whole entire laptop. So if I get a new support case in the future, this is the problem that may arise. If I get a new support case and I said, hey, you know what, I spilled water on my keyboard. The language model was trained to actually say, you're an idiot, go buy a new laptop. And then the customer may say, but I didn't even tell you that it was not a laptop. It's not a laptop. It was actually a desktop with a wireless keyboard. And they're going to be like, well, you're an idiot. Go buy a new laptop. And it's stuck in that belief. So that is what actually, training based on your old thing. It's not that you're training on bad information or fact. It's just that you have to be very careful when you're fine tuning or training. You're creating a whole new structure of how it should respond to that piece of question or line of reasoning. Hopefully that made sense.
Well, you don't have to be an idiot. You don't have to spill water on your laptop to be an idiot. There's lots of ways.
You're right.
All right, now let me do one more takeaway. Social media management. So you can create a clone that drafts your Twitter posts mimicking your unique brand humor. So again, this is all just priming the pump. It's that lesson that you gave us earlier, where it's doing it over and over and over again. Think about all the Twitter posts, Facebook posts, LinkedIn articles, and stuff like that you put out in the workspace. If you're putting all of that stuff in front of a training model, that training model is learning how to become you. And if you want to be automating part of who you are, whether it be for ghostwriting, customer support, or social media management, you're in the right class.
Yep, exactly right. And some technical things, custom coding assistance. Say for example, you can actually make your code base itself look exactly like your style. No, there are linters and stuff formatters that allow you to do that now, where you can format your curly brace on the same line or a new line. But you can actually make it generate the code natively in your style. Things like offline privacy, so run highly sensitive legal or medical analysis on local hardware where the data never touches the cloud server. So if you actually don't want to blow up context, you can actually train the actual data to believe something that is actually factually true. Now, keep in mind that the drawback is the information may not be true, right? It may just be a piece of information that is speculative, but by telling it that, it now believes it's true. So keep in mind those things as well. And edge devices, so you can deploy tiny specialized quantized model on mobile phones or IoT devices for specific tasks that you train it specifically for. All right, yeah, Jenny. I know this was a heavy show, lots of technical stuff. Does anybody have any questions on training the actual model and fine-tuning it yourselves? Anything in the live stream?
I have a question from the Peanut Gallery. You want to do a couple of questions, or do you want to go right to the news?
Sure, let's hit one.
I'm a beginner. How much data do I need to make the AI sound like me?
Yeah. So realistically, right, you're probably going to need about 100 pages of text to sound like you. These large language models are actually trained on tens of thousands of actual pages. Now, because you want remember, keep in mind, the more information you give it, the better it is. Once you actually get to a number, there's a sweet spot depending on the model. So if you're actually looking for a small model, training it on about 100 pages is fine. But the bigger models that you actually get, you have to actually give it a little bit more information to be able to remember that specific thing. So keep in mind, about 100 pages itself might be okay on a small model. You may need 1,000 or even 10,000 trainings as you get up to much larger models.
All right, let's jump to the news. Microsoft and OpenAI rewrite their deal. Check this out. In a massive shift, Microsoft and OpenAI have removed the AGI exclusivity clause, whatever that is, meaning Microsoft no longer has exclusive IP rights until AGI is achieved, though they retain model use until 2032. So instead of coming up with some arbitrary thing like what is AGI and when have we achieved it, it looks like they have that their deal goes for another 6 years. Anything? You got anything on that, JR?
Nope, we're good.
See, $1.1 billion seed for AI super learners. That's you guys. Ineffable intelligence, founded by ex-Google DeepMind principal scientist David Silver, just raised a staggering 1.1 billion seed round at a 5.1 billion valuation to build the next generation of AI. That's nice. Give me $1 billion and I'll start to build it. And finally, Vercel, that's an interesting name. $2 million has a $2 million hack. A $2 million hack triggered by a Roblox cheat download compromised an enterprise AI tool. Isn't that V0?
Yeah, same company.
Exposing critical supply chain vulnerabilities and the urgent need to robust AI agent governance. Junior, please don't tell me to go back to manus.im.
No, it's not that. We can clearly see that all these agentic tools, no matter how good they are, they always have some issues. So guys, if you're actually doing agentic coding, what this should tell you is that even the biggest companies can falter to agentic code. So pay attention. If you actually get something, don't be very careful at what you give these agents and review the architecture and the code, because they're really good at improving efficiency, but efficiency at some cost, and the cost is it's just doing what it's trained to do on tens of thousands of projects. So unfortunately, a little Roblox cheat download itself compromised the entire system. It's kind of silly. So anyway, that's really
well. Whichever is the new agentic leader, I'm gonna have it compile all of my emails from the last 10 years and run a fine-tuning script and have my digital clone answer my inbox for the rest of my days so that I can spend some time to myself. This has been an incredible journey. This season 11 has been. We went from understanding parameters to ripping the internet cord out of the wall and finally teaching our machines to speak just like our own voices. You guys are officially local LLM masters, so give yourselves a hand. Join us tomorrow for a brand new Tuesday. All right, I think I heard Adrian in there. Join us tomorrow for a brand new Tuesday series starting with visualizing the mind. We will be using whimsical AI to generate massive mind maps instantly, so tune in. It's not always as deep as today's show. Come on in tomorrow, you don't want to miss that. Junior, take us out.
Guys, thanks for hanging out with us as always. Remember, these classes are always free live and you can ask questions on Zoom. Sign up for a free Airhead account and RSVP to all our shows and get reminders at airheadinstitute.ai and support us by becoming a paid member. Invite a friend by sharing this episode and inviting them to class. Remember, replays of the classes are always available on YouTube for a short period of time, but just make sure you watch it before it's gone. See you guys tomorrow. Bye.
That wraps up today's AI Power Up. If you joined late or you're new here, welcome to Airhead Institute. This is your daily destination for mastering artificial intelligence. We designed this lineup for everyone, whether you're a technical pro looking to upskill or you just want to chill and learn something new on your lunch break, we've got you covered. Our classes evolve every single month, so you're always on the cutting edge. And the best part? It's totally free to join. Once you're in, you can get live tips on your AI projects in our AI office hours and even enroll your kids in our Airhead After School program. Scan the QR code to join the community right now and make sure to like and subscribe at Airhead Institute on all socials. Guided by your hosts AI Junior and AI Johnny, we're here to help you win. Remember, AI won't take your job, but someone who knows how to use AI will. Don't get left behind. We'll see you next class. Bring a friend.